Bitwise operators and the dot product. The dot product easily being the most common question on any coding interview in game development is going to be, hey, what's the dot product? You're going to get that on every single interview. So make sure you have a good answer for that. It's written right here. This is exactly what you want to say. But anyways, Bitwise operators first. Let's not get ahead of ourselves. The Bitwise operators... Oh, sorry, I wasn't showing it. Here you go. So the Bitwise operators are the AND operator, the OR operator, the tilde, the XOR, and then the left and right shift. So it's pretty common for them to ask you to do one of these operations, and you need to memorize the process in order to complete one of those operations. So for example, they'll say something like this. They'll say, how do you set the third bit of a number? And the answer is you take that number and you OR equal it with 1 UL, right? 1 UL just means an unsigned long. And you're going to shift it over to the left by n, and that will change the nth number. Okay, and similarly, this is how you clear a bit, toggle a bit, check a bit, and checking a mask. You're going to want to memorize these and put them on flashcards and just make sure you can recall that quickly, because it is a little hard to think about in the pinch of time, and you need to have it on the back of your hand. Okay, and then the dot product, aka the vector inner product. So this is, again, the most common question. They're going to say, hey, what's a dot product? And you're going to say, the dot product is a product of two vector magnitudes multiplied by the cosine of the angle between them. It basically finds the angle between. That's the big thing there. It's also used for projections. It's used for angles and projections. Now, how do you remember that it's the cosine? I like to say that the C in cosine looks like a dot, and that's how I remember it. It's going to come up later, but with the cross product, you basically take two vectors multiplied by a unit vector normal to them. You take two vector... Alright, I'll just say it. The cross product returns a vector perpendicular to two input vectors, scaled by the product of their magnitudes multiplied by the sine of the angle between them. So in that case, it's the sine. With the dot product, it's the cosine. With the cross product, it's the sine. And how do I remember that? Well, I think that the S in sine kind of looks like two crossed curves. So that's how I keep the difference in my head straight. With the dot product, it's like a dot, it's a cosine. So that's my mnemonic there. Hopefully that helps you. And then there's just a bunch of formulas which you're going to need to memorize with respect to the dot product. This is the triangle inequality, also known as the Cauchy-Schwarz equation. The dot product is also equal. Okay, so this is exactly what I just said, but in formula form. This is how you actually do the dot product. If you have a two-dimensional vector, you just take the x components of vectors a and b, and you multiply them, and you add that with the y components of vectors a and b. Curious thing here, the dot product can also be expressed as the A times B transpose. So that might happen in a formula. And then the other thing is that you're also going to see vector dot product with itself is the square of the magnitude. So the way that works is you take the magnitude here, which would normally be, multiplying each of the components by itself, taking the sum of that and then taking the square root of that. But you're going to take this, you're going to raise that to a power of 2. So eventually the power of 2 is going to cancel out the square root, and you're just going to have x1 plus x2. So something to think about, that might come up in a formula later. Okay, and then let's talk about projections. So the projection formula I find is a little hard to remember, so that kind of makes me angry, but I've tried to simplify it as much as possible. So here's my simplification. A being projected onto P is going to create vector P. Here's the diagram. Vector P's magnitude is A dot B divided by the magnitude of B, the magnitude of the vector you're multiplying onto. And then P itself is going to be that magnitude in the direction of B normalized. So that's how I remember it. I try to split it up into those two sections, which is the magnitude, A dot B divided by B, and then that value multiplied by, this direction, which is basically just in the direction of B, which makes sense because we're projecting A onto B, so that P should be essentially collinear with B. That's the whole point. We want the projection to be on the same point, on the same line, on the same vector, same thing. Okay, and then the other note is that this expression becomes extremely simplified when U is normalized. We just take the magnitude of A multiplied by the cosine of the angle between A and B. So it's much simpler then, because all these absolute values of B go away because they're 1, because U is normalized. Okay, so that's a simple way to think about it. And you know, very often when you do these calculations, if you're going to be dealing with projecting onto the same vector many times, you'll normalize it just so you can get that optimization. Okay, so here's the unit vector. And the reason why I wanted to mention the unit vector here is because these are all of the different results that you can have from the dot product. And so you do need to memorize these. A dot B is going to be its maximum if A and B are exactly in the same direction. In that case, the result is going to be just the magnitude product. Okay, and the reason why that is because that angle that we're multiplying between them, again, remember it's the cosine, and so that cosine is going to be greatest when they are 0 degrees apart. In other words, on the unit circle, the greatest x value of this red circle is going to be all the way on the right here, where the angle would be represented by 0 degrees on this unit circle. So that is why when they are 0 degrees apart, or in other words, collinear, facing the same direction, you're going to have the greatest result. Now, what's the least value represented by the x? What's the least x value represented by this red circle? It's going to be this point over here, right? So essentially, it's if A and B are pointing in the exact opposite direction and collinear, just the opposite direction, what does that mean? Well, the result is going to be -1 times the magnitude of A and B. The biggest one to remember is, of course, the dot product is going to be 0 if they're perpendicular, and by virtue of that, it's going to be less than 0 if it's an obtuse angle, and it's going to be greater than 0 if it's an acute angle. Okay, and that wraps up the dot product and bitwise operators. I hope this helped you. Good luck on your interview.